Here is the demo for the starSearch simulator. It's written by JavaFX. User can configure the import file directory and export file directory. First, let us try to import one scenario file. So the scenario file determines the dimension of the grid, the position, and the number of the artifact. There are 3 drones here, and 2 suns, and 2 wormholes, and 1 UFO. The drone will try to explore as many starred regions as possible. And the UFO will chase the drone. And when the 2 miss, the drone will be crashed. And if the drone moves to the same position, it will crash as well. If the drone moves to one end of the wormhole, it will come out from the other end. The status panel shows the progress of the simulation. For example, how many squares are explored, how many turns has been completed, how many drones are active. And for each drone, it has 3 kinds of strategy: smart strategy, random strategy, and manual strategy. For smart strategy, they communicate and make decisions based on the shared information. And for the manual strategy, user can input the action for the drone. Whether or not they use manual or smart or random strategy is determined by the scenario file. User can control the pace of the simulation by clicking Next button, or user can click the Fast Forward button, so that the simulation will run from the beginning to the end continuously. So let us try Fast Forward button first. Drone 0 uses manual control, so it has 4 kinds of actions. Steer means change its direction. Scan means scan its neighbor square status, and the square status will be shown on the status panel. And the thrust means how many steps it can move forward. Scan pass means it do nothing. So I will let it thrust for 3 steps. It goes into this wormhole and gets out of this wormhole. The stars on its path will be cleared. I will make it steer to the west. You see the direction change. Unfortunately, it's eaten by the UFO, so the manual control part of drone 0 is done, and drone 1 and drone 2 will keep moving forward using their smart strategy. Smart strategy means when they scan, they have the information from their neighboring squares, and they will share that information with each other. So they will try to avoid the sun and the UFO, and they will try to move to the star position. Because this takes a long time, I will stop in the middle of the process. So when the simulation is stopped, the number of turns completed and how many squares are explored will be show up in this final report visualization. And also a TXT file will be exported to the export directory. And let us try another scenario file. Okay, I will try to use the nest mode. And in this case, the 2 drones are using random strategy. 1 drone is eaten by the UFO. The UFO is using smart strategy. so it will chase the drone. Okay, 2 drones are destroyed, so the simulation is done. So this demo is done, and for the future work, we will work on how to improve the SMART strategy. For example, there is Q-learning in reinforced learning, and there are some machine learning method which could be applied to the drones so that they can be smarter. And also some other artifacts could be tried as well. For example, we can try to use fuel station, and the fuel station could provide fuels to the drone so that the drone can move more than 3 steps. Right now it can only move to 3 steps. If it has fuels, it can move 4 or 5 steps. And thank you so much for watching.